Hi. We've been working with the slope-intercept form of a line, so that's y equals mx plus b. In this video, I'm going to introduce you to another way of writing an equation of a line. It's called the slope-point form of the line. Okay, so I'm going to start by sort of giving away the punchline. The slope-point form of an equation looks like this. It looks like y take away y1 equals m times x take away x1, where the slope is m, and then a point on the line is x1, y1. So I'm telling you that right now, but what we're going to do as I go through this is I'm going to sort of develop it. I'm going to show how we can come up with that. So that will be sort of the last line that I write will be this one here. And this is what I'm aiming to get this slope point form of a line. This is a useful form of a line because reasonably often we don't actually know the y-intercept, and we could calculate it and use slope-intercept form, but it's often easier to use slope-point form, and then we can change this form to get slope-intercept form if we do want the y-intercept. So this is just often useful, because sometimes we don't know the y-intercept. Okay, so before I start into the main thing, I just want to talk about a little idea. It's just really an idea about what the concept of slope means. But it's just something I'm going to use, so I thought I'd just mention it first. Suppose this line has a certain slope, m. If I pick up 2 points on the line, okay, and then I draw in this little triangle here, we often draw this when we're calculating the slope. If I call this delta x, so that just means how much the x changed, or the change in x. So, this might be 2, it might be 150. Then this height here is going to be m times as big as the base of that triangle. It's going to be m times delta x. We also call it delta y. But this idea here, that it's m times as big, this totally makes sense because the slope is rise over run. So for example, if the slope was 2, this would have to be twice as big for that as that, for this to come out rise over run to equal 2. It'd have to be twice as big. Okay, so I'm going to use this little idea. What I'm going to do is I'll start with a specific case, and I'll show you the slope point equation for that specific line. And then I'm going to replace my slope with the letter m, and I'll replace my point with x1, y1, and then we'll come up with the general case. Yeah. So suppose we've got a graph of a line here. It goes like this. And suppose this is the point. Let's have that be the point 1, negative 2. Now let's consider this here. This is just going to be the point x, y. And this point is actually going to be any point. It could be any single point along this line, because those points will always be x, y. Later, when we're talking about a specific x and y, we'll give them the subscript 1 to mean that's a specific point. But this could be any old x, y point. Okay, let's draw in this triangle for a second. Think about what we've got here. Okay. If we look at the length of the base of the triangle here, how long is that? Well, the x value here is x, and the x value here is 1. So it's x take away 1. Okay, and if we look at the height here, how long is this? Well, we were up y here, and here it's negative 2. So it's y take away negative 2, which is the same as y plus 2. And either one of those is sort of equally good. I'll call it y plus 2. But remember that came from y take away negative 2. Okay. So we have the length and the height of that triangle. But, if we use this little idea over here, there's another way we can describe this height. Let's say that this line had a slope of 3. Let's give it a slope of 3. It doesn't look quite as steep as a slope of 3, but we don't know what the scales are on this. Okay, so if it has a slope of 3, then this is 3 times as big as this. Like just from this little idea, that's just all the slope means. So it's 3 times x take away 1. Okay, so that's actually the slope point form of the line. So the slope, sort of as advertised here, the slope m is right here. We've got x take away the x value of a point on the line, and then y take away the y value of a point on the line. In this case, because we're subtracting a negative, it's plus 2. Okay, now I want to make it sort of general, which I'll do in pink. We'll just do exactly the same thing in pink. Suppose this wasn't the point 1, negative 2. Suppose it was just any point x1, y1. Okay? And suppose this slope wasn't necessarily 3, it was just the slope m. Okay? So what we'd have here, how big would this be? Well, it's the same, except instead of being x take away x1, x take away 1, it'll be x take away x1. It'll just be whatever that x value is. So x subtract x1. And then this is y subtract, before we had y subtract negative 2, but now we have y subtract y1, for more general case. And it's also, if we use the little idea of it being m times as big as the width, so it's m times as big as the width. So there it is. So this is the idea behind slope point form. That's why it works, just because of what the slope means. It's really useful because often we'll need an equation of a line to solve a problem, and if we use the slope point form, we can use any old point on the line, doesn't matter which one, and the slope, and we can get an equation of the line. Okay, good luck.